Hi, good morning, everybody. Thank you for joining us on this webinar today, hosted by Adarma and Cribl. I'm James Todd. I'm the CTO at Adarma. I'm joined by Chris Morris, who's a solution engineer at Cribl. Thank you for joining this second part of our series on how to design a future-ready SOC. In part one, we talked about the overarching principles and key considerations for designing a future-ready SOC. In this session today, we'll talk about data pipelining and how we derive value from source event data and ensuring that we acquire, route and process that in a cost-efficient and effective way, driving business outcome. And in part three, we'll talk about how we address security posture management or continuous posture management, and also leveraging AI within the future-ready SOC. We'll have time for questions and answers towards the end of the session. You can post those in the chat and we'll respond to those. So if we can move forward to the next slide, please, Chris. So as I said, part one is available from the link on this website, and we'll also publish that in the chat. The recording of that from a couple of weeks ago, and there's part three is in a couple of weeks' time on June the 19th at 10 a.m. if you want to join us for that session. And the next slide again, please, Chris. So the agenda for today, I'll briefly go through and recap the challenges of the traditional SOC challenges we face with the traditional SOC design, the considerations and overarching view for the future-ready SOC, and how we look at future data acquisition and storage. And then I'll pass on over to Chris to talk about common SOC data strategies, looking at data pipelining from the point of view of Cribl and what they're doing in the market, and then also reinventing data strategy. As I said, Q&A and next steps will follow towards the end. So as we look at the challenges with traditional SOC design, this is a bit of a recap from part one, and what we need to overcome in relation to designing the future-ready SOC architecture for going forward, is looking at a number of issues that we have within the environments that we deploy future SOCs to. So that can include sprawl of tools or prior investment in tools that we need to capitalize on, potential lock-in from vendors as we move towards hyperscaler environments and more of a platform-orientated approach. There's the potential for vendor lock-in and how we either encompass and embrace that or look to avoid it through open architecture approach. The explosion in data, which is a key topic for today in terms of both the volume and variety and velocity that we need to collect from a data point of view to obtain and achieve observability within the environments we're looking to protect. How we tackle ubiquitous encryption and how this is starting to erode our reliance on network-orientated security controls and monitoring, and how we need to go to both the endpoint and the source or service side of event data that we need to collect. Potential fatigue around analysts, so overworking of our analyst teams, and how we use automation and embrace AI in order to elevate the analyst operations and functions within the SOC, and to more interesting activities that limits and reduces that potential fatigue. The evolution of cloud and the greater adoption of cloud technologies leads to a wider set of environments that we need to observe, orientate, take action on and protect. And then the complex operating environments and the increased attack surface and potential fragmentation of our traditional security perimeter that we need to be conscious of and observe and protect as part of a holistic security operations approach. And then we need to look at, and this is the topic of part three, the potential limitations and considerations for adoption of automation and AI within the SOC, and being conscious of what we can achieve from a business outcome perspective from those technologies and the risks incurred with both. So we move to the next slide, please, Chris. So here are a couple of areas that the future-ready SOC must achieve or must be conscious of. So as we said, handle large volumes of data, with the potential to avoid high ingest processing costs and storage costs, monitor and protect a wider variety of environments than ever before. That includes the retained monitoring and protection of legacy environments, and also the move to cloud environments, and also moving in lockstep with organizational digital transformation and other transformation agendas. Embrace federated detection and response model, so a key topic of today's conversation, as well as smart data acquisition, looking at how we leverage and gain access to data that are in those distributed environments that we need to protect. Enabling infrastructure owners to subscribe to security services, so encouraging the use of native security capabilities within cloud environments, and looking at the limitations of and leveraging of controls within SaaS services consumed, and also looking at the accountability of security in terms of a response methodology outside of the security team, and having a organizational wide accountability for security operations. Adopt automation coupled with artificial intelligence and machine learning, and to augment decision making and improve efficiencies within the SOC, so reducing repetitive tasks on our analysts as the first step of AI and automated process adoption. And then take an innovative approach and proactive approach to threat hunting that leverages the latest technologies and techniques. So that's the technologies and techniques that are within the environments that we're looking to protect. So looking at a sort of a vendor first approach in terms of leveraging inherent and embedded capabilities and technologies within that, and providing and layering an innovative approach to sort of coalesce and coordinate that across the protected environments. So we start to build out the future ready SOC. This is again a refresh of what we talked about in the first webinar. So looking at embracing and adopting an open architecture approach to the future ready SOC design. And again, this is sort of looks at how we counter that potential for vendor lock-in by its openness, but within its openness having a defined area of capabilities that we need to address and functions we need to have within the SOC. So again, this looks at potentially integrating digitally native technologies and capabilities alongside the pre-existing tooling within your environment. So we're not advocating a rip and replace. It's much more how we leverage and drive effectiveness in pre-deployed controls, whilst also embracing future and current digitally native capabilities that enhance those previously invested in tooling and controls. The architecture needs to be extensible. So what's fit for today may not necessarily be fit for tomorrow. So looking at an extensible architecture that allows us to adopt new and emerging technologies, being slightly experimental in certain areas where we need to be, but also having a core of credible capability that we maintain and potentially replace in the future. So if we look at the next slide in terms of what we're talking about today, in terms of one of the component elements of the future SOC, is looking at how we address data acquisition and storage and how we're smart about doing that. So a robust SOC needs to gather relevant information from multiple sources. So not only security sources or security event data, but also business event data that provides enrichment and context around the events an instance that we're addressing within the SOC. And that provides a clear pathway to confidence in decision making that's driven through automation and machine learning. The two key considerations that we'll talk about today within data acquisition and storage is the ability to understand the value of individual data sets, and importantly, the features within those individual data sets that support business outcomes and security outcomes within the SOC. And also the ability to extract that data in a smart way, route and store that data efficiently and economically to the right sources within the environment, depending on the operational outcomes. So whether that's more of a retained search over batch data that's collected and stored over time, or looking at streamed data to respond to events in as near real time as possible. So with that overview, I'll pass over to Chris, who will walk through a number of common strategies and approaches that Cribl adopt within their propositions.
Thanks, James. So first of all, what we're going to discuss is just the sort of common data journey. So we're looking at that typical data lifecycle, and it's usually quite a linear approach. So you ingest new data, it goes through a certain number of stages, and over time that, that value may reduce, it may change. So we sort of have that, that real-time data or near real-time data going into, a security or an analytic tool. And then we're going through and it's becoming more historic. We might be looking at more ML type use cases, looking over a wider period of time. Then we may be pushing that to recoverable archive and then into a long-term archive. And then obviously that time can change if an incident occurs, etc. Then that life cycle, you might need to go and retrieve that data from that long-term archive and make that data operational again. The issue that we have, we talk to a lot of customers about, is how do I deal with that long-term archive? How do I ensure that that data in that archive tier is still operational? But also, how do I ensure that I'm not just sending everything through this linear life cycle? Because then that leads on to the cost of that one event. If I'm sending everything through that linear life cycle, ensures that the cost of one event, if we think about, the total ingest costs on a lot of seams, these are going up to, approximately $2 per gigabyte in some scenarios. But then when we add in the cost of that linear storage, that could then, equate to about $5 or $6 per gigabyte. And then not all that data is equal. So we need to have some sort of tiering. I want to be able to optimize that approach. So I'm only sending that relevant data through one bit of the life cycle, but then having the choice and flexibility to then send, right, I need the full fidelity data, but that can go straight into my recoverable archive because I don't need that for that security real-time use cases. So what we're looking at is trying to say, how can we optimize that total data cost and the total ownership, total cost of ownership of that data, and ensure we're not having that linear life cycle of events. So, and again, pushing on to how this is hurting, your budget or your TCO. So again, these analytics tools, you need to meet your compliance requirements. We speak to a lot of customers that, have ever-changing compliance requirements. Governance compliance comes in, rules change, etc., especially in the telco financial sectors. And we may need to go from 12 months to 24 months, but that's not on everything. But because we've got that linear life cycle of the data, it makes it very difficult to say, right, I need to send this data to lower cost storage and be able to store that for 24 months. But then I send this high octane data into fast storage so I can search it and get security value from it. So again, we haven't got much flexibility there. And then we're sending all those events into the system of analysis or into your SIEM platform. And then that then has a knock-on effect, one to the security analyst and two to how quickly you can react. Because I'm sending all of that data, I'm having, searches are running slower, analytic rules aren't as efficient. If we try and use any ML or AI over that, it's not as going to be, as accurate because I'm not feeding it the right data. I'm not feeding it the right fuel. And then we've got, tool expansion. Multiple customers out there, especially in the larger side, but even on the smaller side, we've got 5, 6, going upwards to 10 different systems of analysis. And every time we go and purchase that new tool, maybe for a new business unit or new team, that and then might incur a new agent or a new data collection tier or a new data collection pattern, maybe a cloud function, for example. But this all increases that technical complexity, one, to manage it, but then you've got resource contention problems as well. Every time we add an agent to an endpoint, that then relates to CPU RAM contention. And often we can end up with more agents on the endpoint than there are applications. And then you've got the storage problem. So as soon as I then go and purchase a tool or a system of analysis, I have to, one, replicate all the data collections here, and a lot of the times duplicate effort. But then at the same time, I'm also duplicating the storage. So every single tool has its own storage tier. And then it becomes really difficult to have that cohesive data retention policy. But also then I've got the problem of schema. So all these systems of analysis all have schema that needs to be met, regardless of what tool you look at. So then that fixes me in, it locks me in. And then I end up with data pools everywhere. And then that hurts me from an operational point of view, because then I need my analysts or my users to be able to, one, know how to use those tools effectively. And they have different challenges in terms of one data collection? How do I do all the parsing? How do I do all the searching? But also, how do I have a convergent view of all that data as well? And then again, new tool, more complicated to meet that data governance. If I've got 6 or 7 different tools plus a data lake on top, how do I keep control of all that data? And how do I keep the governance to ensure that I'm getting those compliance? And also, how do I make it operational? So if something does happen, I can react very quickly as well. So looking into, what us at Cribl and what we are dealing with. So again, we go into, data growth is growing at an extensive rate, 28% roughly what we've got from market data, and just looking at, the ever-changing initiatives going on in an organization, the move to cloud first, hybrid, some people coming and, stepping back from cloud and coming back more and self-hosted. But again, all those different tools, applications, remote working, etc., are ensuring that data growth is growing. And then because of the current macroeconomic climate, the IT budget growth is either not climbing with it, linear, or in some cases reducing. So again, we can't keep up with this constant data growth. We need a better way to be able to deal with that and have a better story in terms of TCO and ROI. So we all recognize that data has got different value, variety, and volume. So value can change over time. So for example, data may go through a system. It may not be valuable that first 3-6 months, but then there's a breach or there's a compliance use case, and that value then may jump up for data that was 9-12 months old. Ever changing, not all, or you can't really put a boilerplate tag on value, because different data means different things to different business units within an organization, but then it also means different things to different organizations as well. So again, it's very difficult to say, well, this is no value and it's going to carry on with zero value through its life cycle, because things change, things happen, and we need to be able to react quickly. All data's got variety. So when we're talking about variety, we're talking about, the different formats, XML, JSON, CSV, key value pairs. How do we deal with all that different variety and get it into a common schema to make it easier to report on and react with as well? And then we've got the different volumes. Again, data is not linear. It peaks and troughs. If you look at streaming companies, for example, day to day, they may be only ingesting, 2 terabytes, but then on an event, they may be ingesting 10, 20 terabytes, etc. So how do we deal with those ever peaks and troughs? Ensure we've got, one, the data collection and ingestion tier fit for purpose, but 2, how do we deal with that on the system analysis and storage side as well? So Cribl, here at Cribl, we're really positioning ourselves as the data engine for all IT and security. And what we're talking about in terms of that data engine, we're really focused on melt data, so metrics, events, logs, and traces, and that's both over IT and security spheres, but then also the opportunity to converge that with business data as well. So if we look at that common picture that we see in a lot of different customers, we've got various different systems of analysis there on the right, and then we've got you buy a tool, you install an agent, or you stand up a cloud function, and then you need to get that data from different networks, so whether that be like perimeter firewall switches, etc., all the way through to servers, endpoints. And then what happens is, if we're serving up that different data to different business units, we end up with duplication of effort, because a lot of the time we're taking the same data and then we're transforming it and sending it to different output schema. So again, we've got duplication of effort. We've got pressure on infrastructure and engineering teams to manage all that infrastructure. How do I keep it upgraded? How do I keep it patched? How do I keep it highly available as well? But also, I've got no centralized control. I've got no way to look over all the enterprise. I need to look at the data that I'm collecting from multiple different clouds or multiple different data centers. And I want to have a centralized view of all that data that I'm collecting and have, more of an effect. And, you might have gone through a period of being able to build your own. So maybe you've looked at building your own sort of transformation, but often that's linked to a particular vendor, or it only sorts out 10-20% of the problem. We're not doing anything holistically over all those different data patterns and different data platforms that we need to get that, need to get all that data to. So looking at Cribl and looking, at the unified, what we call that data engine, we've got a number of different functions that operate within that platform. So we've got Cribl Stream, which is our flagship product, which is all about being that universal receiver and translator of data, being able to take that protocol first driven approach to be able to get the right data to the right destination at the right time in the right format. So being able to take all that data from all those different network endpoints directly. So things like switches, negating the need to go and stand up dedicated syslog infrastructure, even branching into being able to agently collect Windows event data. So making it easier to, ingest that data, optimize it. So ensuring that we're not sending everything downstream to those systems of analysis, then also given centralized control how we can collect data from those different data centers, cloud platforms, etc. And then we've got Cribl Edge, which is that ability to then have that centralized control over data you collect off different endpoints, and that can be Windows, Linux, K8's containerized environments. But trying to negate the problem a lot of people have, where they install an agent, it becomes a black box. And if we go through the period of trying to even do something simple like monitor a file in var log on a Linux box, for example. Again, if we think about the normal standard process, we have to get a change window, then we have to get backend access to that box, then we crawl through the file system, we apply our relevant config. The first time we see the data is when it lands at that destination. We've got no validation, control, and checkpoint. And that could take 4 to 6 weeks in some organizations once we've got that through, including the networking. What about if I could go into a centralized control plane, explore that node in that control plane and be able to say, right, ingest this file, validate the data is in the correct format, and then push that through to the destination. And then we've got a more effective way to be able to store that data as well using Cribl Lake. So Cribl Lake is all focused on, if we think about, a lot of the data lake technologies out there, a lot of them weren't built, they were more built for business data. They weren't really built for melt data, so metrics, events, logs, and traces. So we want the ability to manage that object storage layer a lot more easier. So we've got to think about read and write costs. We've got to think about IAM policies. What about if we could take that, a lot of that, restrictions and a lot of that, complexity away and make that a lot easier to say, right, I just want to be able to store this data for, 2 years within object storage. And I can all do that through a low code approach, but then I'm not having to worry about lifecycle policies, IAM policies, etc. But then the biggest thing that we're doing here when we're sending to Cribl Lake or object storage is we're not applying any schema. So my data is not locked in, because when it goes down to one of those systems of analysis or one of these destinations on the right, it has to apply to that schema. But when we store it in Cribl Lake or object storage, we store that in a vendor neutral format and adding compression on top. So one, it's more cost effective. Therefore, you can keep a more lean data set in your security and systems of analysis while keeping, long-term retention policies in that object storage or Cribl Lake, for up to 5 years, etc. So again, you've got that flexibility. Then we negate the need to have that dead archive where you can't operationally search it. So if we think about that data lifecycle policy you went through, a lot of people use an archive, they might use an NFS share, they might use an S3 bucket, but it's very difficult to get operational insight very quickly because maybe I've got to rehydrate that data. Very difficult to go and rehydrate it very quickly. So we can use our search in place technology, Cribl Search, to be able to search that data in place without indexing it. So it can, search it where it resides. I can get insights. So if we think about more long-term security use cases, that may be an IOC. You may be given an IP with a certain time, and that's all your parameters. I don't really want to have to try and push that into a system of analysis because I might meet the problem where I need to go and search multiple different indexes or multiple different tables. What about if I could have a federated view over all that data and go and search for that IOC very quickly, get my insights back, and then I've got the ability to route those results back to Cribl Stream, that universal receiver and translator, and send to my destination, therefore making my data more operationally effective. So what we believe at Cribl is that your data is your data. So we're giving you more choice. If you want to pivot between tools, you want to send to multiple different tools, you can have, more of that control over that data, right? So you're able to make those decisions. I need to send to tool A, tool B, tool C. I don't need to go and install linear one-to-one data collection and ingestion and transformation for each of those different tools. And then how do I ensure that I've, thinking back to that variety and value of data, how do I ensure that I'm not sending all my data to that fast, expensive storage, but I'm having control to be able to optimize it and say, right, I need to keep this data. I need an insurance policy. I can't just filter it all out and drop it on the cutting room floor. What I need to do is be able to send this straight into an operationally live archive and not be locked into that vendor. So I need to have that flexibility to be able to use that data where I need it to go. So if I need to go into an alerting tool, if I need to go to an IT ops tool, we're then making that cohesive data sharing a lot easier as well across the enterprise. And what that's allowing you to do is to access more data. And we know if we can optimize and not send all that data into those systems of analysis, a lot of customers we speak to have got a lot of backlog of data because they're making choices that they'd rather not make because I can't go and onboard data source A because I'm at my storage or licensing capacity within that within that certain tool, but I'd love to get on this and this to improve my coverage and overall monitoring strategy. So what we can do is we can optimize that feed, allow you to clear that backlog, and and again get better visibility over your environment, but then also ensure that data is operationally active, which allows you to make better decisions. So you can make better decisions, and that can be driven. So think about use cases where you can look at, okay, we're getting a lot of false positives on this this analytics rule. How can I then go back and ensure, right, have I got the right data that I need to really, make sure this alert is efficient and effective? So then I'm making better data-driven, better data-driven decisions because I'm able to go and validate that data before I send it down to a destination. And then once I've got that optimization and that sizing, etc., correct, that means that I'm not over provisioning storage or over provisioning CPU and RAM, etc. Or if I'm in the cloud, I'm not, over provisioning instance types, etc. So therefore, I've got a better TCO. My searches are running a lot quicker. So my security analysts are happy, my IT analysts are happy, etc. And we're making their life a lot easier because what we often find is people will blame the tool first. When a lot of the time it's the data being fed into it. If we're not feeding those tools the right data product, you're not going to get the right insights. Everyone's going to be unhappy, and they're not going to have a good experience on that tool. So that's often when people look at pivoting because they think a different tool will solve that problem. So when we look at reinventing that data strategy and just bringing into, if we look at how can we deal with that problem, overlaying Cribl over the top. So again, having the ability to have that universal collector translator of that data, be able to send some of that optimized right data down to real-time use cases and that alerting piece, but then being able to say, right, I've got my insurance policy of sending all my data into lower cost, vendor neutral object storage or Cribl Lake. Then if I need to go and access that again, I can do in a granular fashion. I can replay that data back, get it back to a different system of analysis or the same one originally that I was sending to. Or I've got the ability to have a better search capability to search that data in place where I don't need to worry about indexing. I don't need to worry about schema, etc. Again, a more flexible, operationally effective approach to ensure that data just doesn't get lost and I'm not just sending it into an NFS share or into object storage with no retrievable or actionable way to get insights from that data. So we're decoupling that system of analysis with that system of retention as well. And then, looking at that, what that does for, the cost and the TCO. that ensures that because I'm not sending all that data to that system analysis and I'm making relevant decisions that are data driven and use case driven, that means that that cost of that one event reduces significantly because I'm not sending all that data to that real-time use case, that fast storage, etc. I'm having the ability to then say, right, actually, a portion of all this data can go into that more recoverable archive, operationally live, but I'm still ensuring that I'm feeding the security real-time use cases with properly formatted, better contextual data, and therefore, I've got a better security posturing over that piece as well. And then this helps you from a number of different, so looking at that compliance use case, I can access that data when required. I've got an optimized data set in my SIEM, so that's reducing the overall TCO. I can onboard that backlog, which is really key. I'm not having to go and spread a new tool or a new data collection method every time a different system analysis comes in. I can then pick my format. I've got my universal receiver, my translator via Cribl Stream, and I'm able to then fork that data into the relevant format to any of those different destinations. And then because I've got that unified object storage or using Cribl Lake, I don't have to allocate different storage elements to all those different tools. If I purchase a new tool, I can keep that nice operationally active data store there. But then I also know that I've got my full fidelity copy of that data in object storage or Cribl Lake. And then we're trying to negate that problem of where you've got those data pockets or data silos of different pockets of data around this system, but how do I cohesively join that together? And that's where Cribl Search comes in, to be able to search over that, all that full fidelity data, but do it in a vendor neutral way without the indexing and schema that's applied on top of that as well. And that is my piece. Just moving into questions. Any questions at all on the floor?
I think we've got a question that came in before the event, Chris, on for you, I think, is how do day-to-day operations and processes change as a result of moving to this type of implementation?
Yeah, so what we often find is we talk to a lot of security analysts and people on the pointy end, is a lot of the time a big portion of their job, could be 50 up to 70% of their time, as a lot of the time is looking after parsing and data collection, etc., rather than doing day-to-day alerting, reporting. So with Cribl, we can then abstract that layer a bit more and ensure that if we're getting the right data in, the data collection tier is a lot easier, the parsing optimization is a lot easier. That means that these analysts can spend more time on the job that they signed up for, rather than data collection and optimization, etc. as well.
Yeah, absolutely key. I agree. It's a key tenet of what we're looking at in the future SOC, is to drive that efficiency in our not only our SOC team, but also the associated teams that do focus on data acquisition and data engineering, and improve their way of working as well, and sort of elevate their interest into sort of key areas within security operations beyond data wrangling and parsing, which they've had to do as part of their day job previously. Just leave it for a little while in case any further questions come into the chat. While we're waiting for those, just like to thank Chris. Thanks very much for presenting. It's a key aspect of our architecture, and Cribl are a key partner of Adarma as we progress through our existing and future managed services together. So it's as we said on the initial call, that we've designed an open architecture that is abstracted and removed slightly from technology type and vendor type, but when we go through to the realization of what we do as Adarma of that future architecture, Cribl is our sort of primary, if only, partner in this space of smart data acquisition and federated search that enables us to do what we do in terms of analytics and event investigation on top of that optimized data collection and storage. So key partner for us, and there's a few questions coming in, hopefully. As I think hopefully you can see, is that it's a excellent solution fit for what we've defined within our architecture. Question for you again, Chris. Do I need to purchase the full Cribl platform, or can I start with specific areas I'm missing, like your stream product, for example?
Yeah. So it's a unified approach, right? So you've got different ways and different models, but what we're all about is being able to have, flexibility. So you don't have to go and have another SKU item if you wanted to use search and stream. But our whole mantra is landing small on a very driven use case, a very consistent pain that you may have within your organization, and then expanding that out, because then you've got more of a maturity. So data collection, security, or all, any of the sort of those strategies should be a maturity model, right? So we're not saying you need to rip and replace anything. It needs to be we need to be able to land in, deal with pain, and then we expand out from there, because we're making it more operational. It doesn't need to be that big bang approach. And this is why a lot of people are locked into different vendors, because the thought of doing a 24-month migration project scares the hell out of everyone, right? And people don't want that on their resume if it goes wrong.
Yeah, absolutely. And a linked question, which I can take, which is, what practical first steps can I take to move to a future ready or next gen SOC model? I think today's topic is really important to that. I think beyond understanding the value of the data that you're collecting, and that goes from taking a threat orientated and business outcome approach, is to understanding what your environment looks like, what you're trying to protect, and what you need to acquire in order to provide observability, monitoring, and response around protecting those infrastructures. So understanding what you're looking to protect, understanding the environments that those assets reside within, and importantly, what are the key assets within those environments that underpin either, as Chris said, regulatory activity that you need to conform to as a business, those functions or services that form key aspects of the products and services that you provide to your customers, and retained uptime around those services. So really understanding what you're trying to protect, what the business outcomes are, and then look to what you have within your organization's previously invested in, the tools and technologies, the controls that are either efficient or could become more effective through an overlay of the future ready SOC model, and then move into looking at what needs to supplement those pre-existing controls and capabilities, either internally or from third parties, including service providers. So I think, as we said on the prior session, the future ready SOC architecture can really be used in a number of ways. One, to evaluate what you currently have and looking at where you need to mature in certain areas. As Chris said, it doesn't need to be a big bang approach. It can be incremental. Looking at evaluating or selecting third parties that will provide the future SOC architecture or component elements of that future SOC architecture, and also looking at how the future ready SOC architecture aligns to other business initiatives. So it might be a migration to cloud or a transition to digital native operations, looking at what you need to do within an organization that the future ready SOC architecture can provide those guiding principles or blueprint to do that. So hopefully that answers that question. We've got a couple of minutes before we're scheduled to close at 11:45. Is there any further questions? Any closing remarks from you, Chris? Or
no, I just think, again, just highlighting that point of, we're not looking at ripping and replacing, right? We're looking at complementing. That is the whole mantra of Cribl as a company. Is that integrations from whether it's a source or destination, and again across the environment, so IT, ops, and security, etc. as well.
Absolutely. So thank you for joining, everyone. I don't think we have any questions coming in. Thank you, Chris, for joining us on this session.
Thanks for having me.
No, absolutely, our pleasure. The link to the full report, the full document around Future Ready SOC is available in the chat and also from our website. Link to the previous recording of part 1 is also in the chat, and we'll be publishing and posting links to the recording of this session if you want to go back and revisit any of the topics that we've covered today, or want to share with colleagues that couldn't make the webinar today. So thank you very much for attending. Hoping to see you on the part 3 of this series. Thank you.